Mathematicians classified numbers into different types according to the gradual development of numbers, starting from the natural numbers 1, 2, 3, 4, and so on. These are also called counting numbers because these were the first numbers ever used by man in counting. After the number 0 was introduced, the set of whole numbers was discovered. The whole numbers start with 0 and going up 1, 2, 3, and so on. All of the natural numbers are part of the whole numbers, but there is one whole number that is not a natural number, that is the number 0. Now we come to what are called the integers. The integers include 0, natural numbers, and the negative numbers. All of the whole numbers and natural numbers are integers, but not all of the integers are whole numbers and natural numbers. These are the negatives, -1, -2, -3, and so on. Taking a step ahead brings us to what are called the rational numbers. A number that can be written as the fraction p upon q of two integers is a rational number, where the denominator q is not equal to 0. Since q may be equal to 1, the integer 3 is also a rational number because we can also write it as 3 by 1. Hence, every integer is a rational number. The mixed numbers are also rational numbers because they can be rewritten as the fraction. Like 1 whole 1 by 2 can be rewritten as 3 by 2. All terminating decimals are also rational numbers because they can be rewritten as fractions. Terminating decimals are the decimals which contain a finite number of digits after the decimal point. We can rewrite a terminating decimal 1.2 in a number of ways as a fraction, but one way is 12 by 10. Also, all non-terminating recurring decimals are rational numbers because they can be rewritten as fractions. Decimals are called non-terminating recurring decimals if a digit or a pattern of digits in the decimal part keeps repeating itself infinitely. We can rewrite a non-terminating recurring decimal 0.33333 and so on as a fraction 1 by 3. All of the perfect square roots and cube roots are also rational numbers because they result in integers. Integers are rational numbers. For example, square root of 4 and cube root of 8 result in 2, which is integer, hence also a rational number. Hence all of the perfect square roots and cube roots are also rational numbers. That means a number is said to be rational number if it can be written as fraction p by q of two integers, where the denominator q is not equal to 0. Coming up next are the irrational numbers, which are the opposite of rational numbers. A number is said to be an irrational number if it cannot be written as the fraction of two integers. Irrational numbers are usually non-terminating, non-recurring decimals. Non-terminating, non-recurring decimals are the decimals which neither end nor have a repeating pattern, so they cannot be rewritten as the fraction p by q of two integers, where q is not equal to 0, like 1.35289014 and so on, is an irrational number because it is non-terminating, non-recurring decimal. Non-perfect square roots and cube roots resulting in non-terminating, non-recurring decimal are also irrational numbers. And what about square root of 2? When we find the value of square root of 2 using calculator, we get something like 1.41421356 and so on, which is non-terminating, non-recurring decimal. Hence root 2 is an irrational number. The constants like e, pi, resulting in non-terminating, non-recurring decimals are also irrationals. Now taking final step out brings us to what are called real numbers. Every rational and irrational number is a real number, but any real number is either rational or irrational number, but not both. Now it's time to move to exercise. Pause the video, read the question and answer it, and play when you are ready. Comment below that how many questions did you get correct from the exercise. If you found this video helpful, give it thumbs up. Subscribe the channel and click bell icon for more videos.